Hello there. The factor label method is one very convenient way to make sure that you convert between your units and get it right, even when there are many steps and the math gets complicated. They call it the factor label method because of how important it is to label the units on all the factors in the calculation. This helps you keep track of where you're going. A very common everyday example where we're exposed to this challenge is in cooking. I'll use a recipe as a very simple example before trying a harder one. So, your recipe calls for a half cup of flour. You look around everywhere and you can't find your measuring cups. You only have measuring spoons. So you want to figure out how many tablespoons of flour is equal to a half cup of flour. For the factor label method, you need three things: the unit you're starting with, the unit you want to get to, and any conversion factors that you need to get there. Conversion factors are like translators. They get you from speaking in cups to speaking in tablespoons. So before I move on, the reason we call the starting unit is because you know the quantity. So we know in this problem that we have a half a cup of flour. The ending unit is the unknown. We want to know how many tablespoons is equal to that half cup of flour. Therefore, you'll also need to know how many tablespoons are in a cup. This is a factor that you can just look up. And I looked it up earlier, and it is 1 cup equals 16 tablespoons. Another thing that you need to know is from basic arithmetic. So when you divide two things, when you divide one unit by itself, it equals 1, and the units cancel. This canceling can also take place when there are a bunch of division problems multiplied together, so you can actually cancel across the multiplication sign. From your starting unit to your ending unit, you want to get all of the units to cancel except the one that you want to end up with. The factor label method is simply a string of factors or division problems multiplied by one another simply for the purpose of canceling the unnecessary units. So let me show you what that looks like in practice. You have a half a cup of flour, and you're going to multiply it by a conversion factor where you have cup on the bottom because cup is on the top here. That allows you to cancel the cups and end up with tablespoons. The next step that you need to do then is to calculate the number. Now that you've got your units canceled, you can go back and do the numerical part. So we'll pull up the calculator, and we're going to do 0.5 times 16 divided by 1. The reason that we did that is because you're to multiply by all the top numbers first and then divide by all the bottom numbers. And your answer is 8. Therefore, you need 8 tablespoons of flour to get to 1/2 cup of flour. Another application for the factor label method is when we're moving from mass or weight to volume. You can't easily go between weight and volume without knowing the density of the object that you are measuring. So density is basically a conversion factor between weight and volume. So it's written as some mass per some volume. For example, a cubic centimeter of wood is much lighter than a cubic centimeter of gold. Gold has more mass crammed into the same space when compared to wood. Therefore, gold is more dense than wood. Every substance on Earth has its own density, like I said, usually in a unit that is some mass per some volume. For example, the density of wood is 0.77 grams per cubic centimeter, whereas the density of gold is 19.3 grams per cubic centimeter. Therefore, if you want to know which weighs more, 5 cubic centimeters of gold or 100 cubic centimeters of wood, you would use the factor label method to compare them. So even though this block of wood is 20 times larger than this block of gold, we still need to figure out which one is going to weigh more. So we'll take our known, which is going to be 5 cubic centimeters, and then fill in our conversion factor, which has centimeter cubed on the bottom and the unit we want on the top, which is grams. We want to know the weight. Cancel the units, and then we're going to multiply across the top. 5 times 19.3 equals 96.5. So a 5 cubic centimeter block of gold weighs 96.5 grams. Now, if we're to do the same calculation with wood, we have 100 centimeters cubed of wood. You cross out the centimeters, multiply across, you're going to get 77 grams. So even though this wood block is 20 times larger than gold, gold is still going to be heavier. So we'll do one more example. We're going to make it kind of a silly one, just to drive the point home, that you can basically use this method for converting between any kind of unit to get to any other kind of unit. So, how many basketballs can be carried by 8 school buses? Your starting unit is 8 buses. Your ending unit is quantity of basketballs and your conversion factors. So, say for example, in this particular problem, you only have the following information to work with to solve it. One bus is 12 cars, 3 cars is equal to 1 truck, and 1,000 basketballs fit in 1 truck. So these are your translators. They're your go-betweens from your starting to your ending units. So we do first is we do 8 buses, and then we pick a conversion factor that has buses on the bottom. So looking back at our list, 1 bus is 12 cars. So we have buses on the top, buses on the bottom. Now we need to have a conversion factor where cars are on the bottom. Cars on the bottom, trucks on the top. Last but not least, we need to get to our ending unit, which is basketballs. Conveniently, we have one where truck on the bottom, 1,000 basketballs on the top. Now, just as a note, if your conversion factor happens to be written the other way, it's perfectly acceptable to flip it over to make it work. So now we're going to do the calculation across the top, cancel all of our units. Now we're left with basketballs. So let's do our calculation. 8 times 12 times 1 times 1,000. Now we're going to divide by the bottom. You don't need to actually divide by 1 because it'll equal the same thing. So divide by 3. And so your answer is 32,000 basketballs will fit into 8 school buses. Those are my 3 examples of how to do the factor label method. There are many more complicated examples you can try, but that is the basic idea. Thanks.